All right, now we're going to look at absolute value inequalities with one unknown. So come with me to algebra with one unknown. Now we have done absolute value equations. Now we're going to get to the most difficult thing in one unknowns that we do in Algebra 1 with one unknown. With one unknown. Not unknowns, unknown. Absolute value inequalities. Now, I know it's going to be hard for you to believe, but I studied this when I was 9th grade, and I'm 72 years old now, and I remember how I did this when I was in high school, because I didn't really get everything that the teacher was explaining to me, but I understood the absolute value equations perfectly. And when he started in on the absolute value inequalities, I was a little lost. So what I did every time he gave me a problem like that, I would solve the equation, pretend it was an equation, solve the equation, and put the dots on the number line. And I would use an open circle if the equal sign was not on the inequality, and I would use a closed circle if it were. And then I would test the intervening intervals to see if they belonged in the answer or not, and then I would shade those in, and I always got everything right. It was only later that my mind developed to the place where I could actually understand what was going on. Now, let's look at this. I've got the absolute value of x is less than 0, and right now there's an open circle, there's nothing here. If I click on greater than, it says the absolute value of x is greater than 0. It should be everything except that 0. I have an error there. And let's put some numbers in here. The absolute value of x, let's just take a number, like a nice comfortable number like 2. The absolute value of x is greater than 2. This is going to be everything that's 2 or greater, or everything that's less than negative 2. I had trouble understanding this less than negative 2. I hope you can see that if this had been an equation, I would have found 2 and negative 2 as my points. And you can see that they divide the number line up into 3 sections. And so my self-defined way of doing it was to put 0 in here and say, is the absolute value of 0 greater than 0? No. So the 0 and all his friends did not need to be shaded. I come up here and did 3. Absolute value of 3 is greater than 2. True. So if 3 needed to be shaded, so did all his friends in that section. Negative 3. So the absolute value of negative 3 greater than 2. Yes, so this had to be shaded. So I did what was called find the endpoints and test. And you can probably hear my dog breathing heavily. I hope she doesn't start to bark. Anyway, that's the way I solved the problems. But right now I want you to see if it's greater than, if you have absolute value greater than, even if you put another number in here, you always get these two arms reaching out because the absolute value is greater than, meaning it's going out from the center of your absolute value interval. And less than always is this 2 endpoints and then the section in between. And I tried to help my students learn it a little bit sooner, so I said greater, or greater, there's always going to be, it's less than a certain number and greater than another number. And less than was like a sandwich. Less than sandwich. So you'd end up with a sandwich here, and then we would go about solving this. Now I'm going to have to get the marker to show you how I have recently told my students how to work this. I should really fix these so that it shows the endpoints shaded in like I did on the inequalities. But that will be work for another day. Let's try the problems. And I'm going to have to go back and I have the marker down here. Press new problem. Now look, it says absolute value is less than. So right here with the absolute value less than, I know it's going to be a sandwich. It's going to be 2 endpoints, and it's going to be everything in between. And my job is to just find those 2 endpoints. And so that's what I'm going to do. So let's see. I'm going to say that it's a sandwich. And watch the way I set this up. This thing right here is sandwiched in between 2 and negative 2. Negative 2 is less than 2x plus 4 is less than 2. This stuff is sandwiched in between 2 and negative 2. And there were 3 kids in my family when I was small, and so I was not bothered at all by something that had 3 parts. Because if I got a candy bar, so did my brother Bob, and so did my brother Adam. My dad treated us all the same. So remember when we did equalities or inequalities, except for when we had the switcheroo, what we did to one side we had to sort of do to the other side. So right here, what our goal is to get the x by itself in the middle of the sandwich. So what has to go away? It's the 4. So I'm going to subtract 4 from the middle, subtract 4 from the right side, and subtract 4 from the left side. So I'll get negative 6, what I have here at 2x, is sandwiched in between 2x and less than negative 2. I'm sorry, I got that wrong. Now, I want to now get rid of this 2. I bet you could tell me if you were here what to do to get rid of that 2. What is it doing to the x? It's multiplying, so to get rid of it, we would divide by 2. I think my dog needs to go out. So we'll get, I'm going to bring the answer over here. We're going to get negative 3 is less than x, which is less than negative 1. So it looks like my problem is going to be sandwiched in between negative 3 and negative 1. My inequalities are going to go like that. I'm going to have to move this out of the way, and we're going to say negative 3 and negative 1. And see that these are the smaller numbers. X is in the middle, sandwiched in between. Check, we win. Let's do another problem. It's another sandwich. So this is going to be right. If it were greater than, I would click on this and it would be an or. But let's do another sandwich here. I'll bring up my marker. I'm going to sandwich x plus 5 in between 3 and negative 3. And subtract 5 from both sides. I lied. Subtract 5 from all parts. This will kill us off in the middle. We get negative 8. Hope you like that editorial comment by my dog. Less than negative 2. Sandwich in between negative 8 and negative 2. Minimize negative 8 and negative 2. Check, we win. I'm hoping for a greater than 1. Oh, it's still another one. Somebody out there must need one more problem. Let's hope this is all we have to do. So we'll bring up the marker. This time, you tell me. Think about it. My 4x minus 20 is sandwiched in between the 12 that's there and the negative 12. So what am I going to do? I want to get the x by itself. First thing I'm going to do is add 20. Now, if this had had an equal sign on it, then these would have to have equal signs, and these would have to have equal signs. Not any big difference, but. So we're going to add 20 here. We're going to add 20 here. And we're going to get 32. It's sandwiched in between 4x, sandwiched in between 8, and now I'm going to divide everybody by 4. We're going to get 2 is less than x, which is less than 8. My answer is going to be sandwiched in between 8 and 2. So I'm going to get this out of the way, put down 8 and 2, and we're going to win. New problem. Finally, we got a greater than. If it says greater, then what's going to happen is our final answer is going to be some endpoint and all the points going out, and some endpoint and all the points going left. So I'm going to write this one. Either this stuff in the middle, 4x plus 4 is, plus 4 is really greater than 12. This is the greater than side. Or this stuff in the middle, 4x plus 4, is less than, going down this way, the opposite of this 12, which is negative 12. This fact that this has to be negative is something that throws kids off. So now let's see if we can't solve this. I'm going to subtract. I always do this like a sort of a mass production. Subtract 4 from here, subtract 4 from here. I'm going to have to subtract 4 from here. I'm going to have to subtract 4 from here. If I get the same answer in two things, I've made a silly mistake. This is going to kill off the 4's here. We're going to have 4x is less than negative 16, and x is less than negative 4. And this one we're going to have 4x is greater than 8, and x is greater than 2. So I need x is greater than 2, or x is less than negative 4. Two branches. I need negative 4 here and 2 here. So I'm going to minimize this. Can we remember negative 4 and 2? Negative 4 and 2, but it's not a sandwich, it's an or. And the larger number needs to be this. It's got to be greater than this larger number and smaller than this lower number. Check our answers and we win. I'll check to see if we've got another less than. I'm not going to do another one of those. I hope you get the idea of absolute value inequalities. If you do get stuck on a test and don't know what to do, you could pretend it was an equation, find the endpoints, and then test the intervals to see if they belonged to part of the solution or not. That might help you to understand what's really going on. And that is a technique that we will use in higher math, so it wouldn't hurt you to do some problems that way. I hope you can conquer absolute value inequalities. Keep working. This is as hard as it gets on the inequalities in Algebra 1.